first thing I want to go through here is this idea that we have a force on some charged particle if we put it into a magnetic field, if it's moving, right? So we have here some force, okay? And it depends on a few things, right? It depends on the amount of charge, right? Of course. So just like before, we were talking about amount of charge. And here we're going to do, hold on just a moment. I want to pull this up really quickly. Okay. So it depends on the amount of charge, and then it also depends on two things. So I want to draw this out first. Let's say I have a magnetic field here. And we're going to consider this to be simple, the simplest case here. We're going to consider this to be a uniform magnetic field. So kind of like how we did before with our uniform electric field, we're going to do that now, that same thing with magnetic field. Okay, and our charged particle needs to move in here somehow, right? So if we have motion, then we have velocity. Okay, so be careful here because now we have a ton of variables that we're throwing around now. So I'm going to keep this kind of as a small v. I'll put a little vector symbol here on it so you guys don't get confused with voltage, right? And then the last thing here that it depends on, of course, so we have a charge, it's moving, and it depends on the strength of my magnetic field. If I have a stronger magnetic field, there'll be more force. So looking here, I'm going to put this cross B, right? So what I want is this little cross product is going to dictate what the direction of these two things need to be relative to each other. Okay, so cross product. Remember, this means that if these two things are in the same direction, okay, and so 0 degrees, right, between them, then their force, then this cross product becomes 0, right? And then if these two things are perpendicular to each other, then we have the maximum amount of force. So this will be 1, right? So the way that we kind of condense this out, or not condense it, but kind of simplify it for us for use, would be QV be sine theta, right? So theta is 0, this whole thing is 0. Theta is 90, this is 1, so we have the maximum. And so we're always in between 0 and 1 for sine of theta. So this here, just to make a mark here, this is angle between my magnetic field and velocity. I'm going to put the velocity direction here. Okay, so just so you guys remember what this angle is actually talking about, not the angle of my field or you know, anything like that. What we're talking about here is the angle between these two things. So remember this cross product right here. Okay, so we have our three main parts here, but what does this actually mean? So this means that these two things need to be perpendicular to each other in order for this force to come up. So let's say I have a positive charge, okay, and it's moving in the same direction as my magnetic field. In this case, the angle between them is 0. So there's no force, right? So here, there's no force. So let's go ahead and get rid of this. Okay, so what if I move upwards? Okay. So in this case, we do have a force. We have my velocity is upward, my magnetic field here is to the right, so I will have a force. So the last thing that we're missing here is what is the direction? So F. So what is this? Okay, so in order for us to figure this out, we will use the right-hand rule. Okay, so when you do this, we have three parts. Thumb here will be my direction of V, and then, oops, fingers will be direction of B, and then lastly, we have palm is direction, direction of F. Okay, so let's kind of look through what this means. So let's say we have a particle in a magnetic field, and my magnetic field is just like we had in our notes right now. It's kind of going here to what it would be, to the right. So here my magnetic field is going to the right. And then in the example I just gave you, my positive charge was moving upwards. Okay, so my thumb would be in the direction where my charge is moving, and then my fingers would be in the direction of the force. They're kind of mimicking the magnetic field. So they're mimicking those magnetic field lines that I drew. And then that leaves my palm. My palm here is facing, or be pushing with your hand, the direction in which this particle is going to be experience a force, right? So direction of velocity, direction of magnetic field, okay, direction of the particle. This is a good rule to use, and it works really well, but it's not actually as simple as it looks. I have a lot of students that will get confused here. And then even, like I'll mess up sometimes, right? Because um, it's actually not that simple, because there are two ways we use this. There's right-hand rule and there's a left-hand rule, okay? And the only difference between these two things is the sign of your particle, right? So if I have a positive charge, I'm using my right hand. If I have a negative charge, I'm using my left hand, okay? We're going to have other versions of the right-hand rule. We've seen some already where we have a current carrying wire that's in the direction of your thumb, and then your fingers curve around. That's the direction of your magnetic field, right? So be careful with this. So you might think like, well, those are negative charges, right? But those are separate, okay? This is for current carrying wire. This is for motion of a charged particle in the magnetic field. So magnetic field, and it always has to make an L. Don't put them in the same direction. I've seen some students do this also. They're like, all right, there's my velocity, there's my field, so that's my force, right? Now, make sure it's got to be this L shape, right? Other way people do this is they'll use like their three fingers, so if that makes a little bit more sense to you, you can do the same thing: velocity, magnetic field, and then force, right? So if this makes sense, you can just do this little thing with your fingers. All right. So hopefully that makes sense. Anybody have any questions about that? So in this case here, in the case we've just drawn, right? What is the direction of this force? Actually, I want this to be green. Okay. What is the direction of this force? Here, my magnetic field to the right, my positive charge moving upwards. So my force here is going to be into into the page, right? So these are X's I'm using to denote that my force is moving into the page, right? So kind of downward into the screen. So this will be just um, how we can look at the force on a charged particle. Now, just to remind you guys, okay, because it is different, if I have a negative charge moving in the same direction, okay, this experiences the opposite force, right? In this case here, my force is out of the page. So I use these little dots. I'm going to use these little dots to mean like it's coming out. So I'll even put this here as, you know, if this is positive, oops, if this is positive X direction, um, and this is positive Y direction, this here is negative Z, and this here is positive Z in terms of my force, right? So just so you guys know, it's the opposite direction, okay? Because you'll end up using your left hand. You put your thumb, magnetic field, pushing the opposite way, okay?